Multiplying polynomials. So there's just two steps to multiplying polynomials. And the first one is to multiply together the coefficients. And the second step is to multiply the variables. So for example, if you have 3x, and I'm going to show multiplication with brackets. If I use an x, like a times sign x, then it gets confused with these x's as variables. So same with a dot can get confusing with a decimal place. So often in math we're going to be using brackets to show multiplication from now on. But I multiply coefficients, so 3 times 4, which is 12, and I multiply the variables, x times another x, and the rule with these is you add these exponents together so you get x squared. If I have a slightly more complicated one, like negative 5x squared multiplied by 3xy, again, I multiply the coefficients, so negative 5 times 3, which is negative 15. And now I start to multiply the variables. So start with the x's. X squared times another x is x cubed, so you add exponents. And then there's a y. Now, to multiply monomials times polynomials, we have to remember to use the distributive law. And the distributive law is basically multiplying the monomial that is in front of some brackets to each term of the polynomial which is inside the brackets. And an example, if I had a monomial, and I'll just start with an easy one like negative 5, and then I multiply by a polynomial, and I'll just use the binomial x minus 1, then I'm going to multiply this monomial to each term of this polynomial. And I'll show it with green. I'm going to multiply these two things together, and then I'm going to multiply these two things together. And if I do that, I get negative 5 times x, which is negative 5 times 1, which is negative 5, and x. And then I get negative 5 times negative 1, and two negatives equal a positive, so I get positive 5. Let's take a look at an example with a trinomial. If you have 3x squared and it's multiplied by 4x squared minus 3x plus 7, you get, and again, I like to show the multiplication with these little lines, the distribution law with these lines. And so 3x times 4 is 12, and x squared times x squared is, add exponents, x to the 4th, minus 3 times 3, which is 9. X squared times x is x cubed when I add exponents. And plus 3 times 7, so plus 21. X squared doesn't multiply by any more variables, so it's just x squared. One more example like this. But this time I'd like to use Algebra Tiles to show you why it works. So if you have 2x and you have x minus 4, let's see what this looks like with some Algebra Tiles. And for that I'm going to need a little bit more space. And by the way, I should get, and I'll just solve it over here on the side, 2x squared minus 8x. So let's see if that's what I get. With Algebra Tiles, we're going to do a little bit of geometry. So here's an x, and here's another x, and together that's 2x. And in another direction, I'm going to show you x, take away 4. 1, 2, 3, 4, all next to each other. So x and minus 4. And what the resulting shape is in terms of geometry, this is like an area question. And so if I take a look at this shape that's created on the inside here, it looks something like this. And a positive x times another positive x gives me an x square. And you can actually see this looks like, if I fill it in, it looks like it's a square and it's x by x. So it's a x squared shape, like the algebra tiles that we have. And x by x is another x squared shape here. And then x times, each of these is a little negative 1. So x times negative 1 is a negative x. And x times negative 1 is another negative x, and another negative x, and another, I get 4 negative x's up here. And down here I get negative x, negative x, negative x, and another 4 negative x's. And if I just count that, I can see that there are 2 x squared tiles, and there are 1, 2, 3, 4, 5, 6, 7, 8 negative x tiles. And I can verify that Yes, the algebraic way of doing it on the right is the same as the Algebra Tiles way of doing it on the left. And that's it for today.